You can throw it away. All right. So we are going to start our conversation about proofs that don't involve segments, but instead involve angles. Okay? There is a little bit more of a variety in the things that we might see with our angle proofs. Okay? So we still have all of these properties of equality just like we did with our segments. We also have all of these properties of congruence just like we had with our segments. Okay? We still have a definition of congruence, but this is how it would look like for angles. Measure of angle A equals the measure of angle B. That means angle A is congruent to angle B, so we can go back and forth. Okay? We know that the definition of an angle bisector, much like a midpoint, is cutting our angle into two equal parts. That's something we're going to have to look out for. Okay? Complementary, we know, means two angles add up to 90. Supplementary, two angles add up to 180. Perpendicular means we have two right angles. Okay? And the definition of a right angle is that its measure is 90 degrees. Hey there, bud. Okay. Angle addition postulate. Angle plus angle equals big angle. Are you seeing a lot of familiarity?
Yes. I forgot that we have late start today.
The pressing similarities.
Okay. Okay.
I can see you.
Okay. I am not super concerned about these right here, but what I do have concern about is the vertical angle theorem. We know that vertical angles are congruent. Okay? So there's a lot of information on this page. Okay? I get that. Okay? Let's talk about how we're going to see these in a proof. So go ahead and turn to page 20. Okay. So I want you to just look at that picture. We are trying to prove that those two angles are complementary, and we are given that PQR is a right angle. PQR is a right angle. Does this seem reasonable? Okay, so let's go ahead and write in that we have our given information. Okay, so much like we do with some of our segment things, we have definitions to work with. So if I tell you, hey, this is a right angle, then our next step can be that angle has a measure of 90 degrees. Why can we say that?
Definition of a right angle.
Definition of right angle. Okay. In order for us to say that two angles are complementary, we have to show that they add up to 90 degrees. Well, if I need to show two angles add up to 90 degrees, maybe I should add them together using the segment, or how about angle addition, since we're working with angles? The angle addition postulate. There are a lot more postulates in this one. Okay. Okay, now what happens from step 3 to step 4? No. Okay. One little thing changed, right? Yeah. One little thing changed. We took measure of PQR and we replaced it with 90. We can do that because of substitution. Okay. Conway, what's our last? Definition of complementary. If two angles add up to be 90, then by the definition, we know they are complementary.
I am confused about number 10. It's like with the mixed with.
So basically, anywhere there's a blank, I want you to fill it in. So what's this reason?
But then, like, why is there a given right here?
So since there's 2 pieces of given information.
Okay.
Okay. All right. In proof number 2, I'm going to go ahead and mark my diagram. Angle 2 is congruent to angle 3. Okay? It's also telling us that angle 1 and angle 2 are a linear pair. Ugh, I can't fit that all in. Is it okay if you put 2 givens in 1 line?
Yes.
Yes. Is it okay if you put 2 givens in 2 lines?
Yes.
Yes, I'm very flexible. Okay. Now, because angle 1 and angle 2 form a linear pair, what do you think we can say with that?
Their angles add up to 180 degrees.
So you're telling me the measure of angle 1 plus the measure of angle 2 equals 180? And what would our reason be? You know what? Let's just say definition of a linear pair. Does that sound good? I mean, isn't that the definition of a linear pair? Angles that are adjacent and supplementary?
Yes.
Okay, I'm okay going straight there. Now, okay, if our last step needs to be that angle 1 and angle 3 are supplementary, like that's where we have to end. You don't have to write it in now, but that's our goal. What does our second to last step need to be? They need to add up to 180 degrees. So I need to somehow find a way to get angle 1 plus angle 3 equal to 180. Natalie? Okay, can we do substitution right now? No. We first have to say that the measure of angle 2 is equal to the measure of angle 3 by the definition of congruence. Up here it's congruent. Here this is an equation with an equal sign, so we need to convert that. Now we can say, hey, the measure of angle 2 is the same as the measure of angle 3. Didn't even need that last line, did I? Okay, so now that we can say that the measure of angle 1 and the measure of angle 2 add up to 180 degrees, can we now say, oh, hey, 1 and 3 are supplementary? Yeah, based on the definition of supplementary. Was that one that bad? Oh, it's not that bad. It's not that deep. We're good. You're going to see a lot of similarities in the things that we need to do in our segment proofs and in our angle proofs. There seems to be a lot of side conversations. Is that because we have a question or because we feel super confident?
I'm very confident.
Okay.
No, it's opening it.
My dumpster fire. Okay. What I want you to do, I don't want you to write anything down, but I want you and your table to talk through what do you think we need to do in order to get to angle 1 is congruent to angle 2? Sorry. 2 congruent to 3. Talk through it. See what you think.
1 and 2 are 1. 1 plus 2
And then you can do a substitution.
angle 1 with angle 2. Because like angle 1 equals angle 2. Angle 2 equals angle 3 because it is
I think one is like 30 degrees.
All right. So let's talk about this. What are some ideas that you have? Micah, what's your idea?
Angle 1 and angle 2 added together equals 90. So, like, if you put up you would see that both have angle 1 in the thing. So, like, simplifying it, they would be congruent.
Okay, great. So angle 1 and angle 2 form a right angle. So since they form a right angle, we first need to establish, okay, since they form a right angle, angle 1 and angle 2 are complementary. We need to say that first, okay? Well, you know what? I'm gonna reverse. I'm sorry. I'm just based on if they form a right angle, what does that mean? It means that they add up to be 90 degrees. Okay, go and put it in the top drawer, bud. Okay. And then we do what?
We substitute angle 1 for angle 3.
We cannot do that.
You can do,
But what we can do is we can say, hey, I have two things that equal 90.
add
And since I have two things that equal 90, I can,
Measure of angle 1 plus measure of angle 3 equals measure of angle 1 plus measure of angle 3.
Then you minus.
take away
Or it's not equal plus, yeah. Then you minus measure of angle 1.
I don't think that's how it works.
Yeah, it
Yes,
is.
it
You
is.
do that.
what's wrong? What's wrong with this?
Oh,
nothing.
we need a symmetric it because they're.
Huh?
Because angle 2 is on this
Then you
side.
subtract angle 1.
First, we need to do subtraction. Measure of angle 3 equals measure of angle 2.
Because we did the given in 2.
Yeah, sorry, guys.
No, we just do that.
Well, we're going to have two more steps, and part of that's my fault. Like Hayden said, we have angle 2 on the wrong side, so we're going to have to use the symmetric property. Then we can use the definition of congruence to say, hey, our angles are congruent. Yeah.
I didn't look terrible.
Oh, it's light. That's light.
Okay.
2 minutes of work.
Now, what I will say is that we do have some algebra that we get to do within this section. So could you turn in your packets to page 22, 23? Yeah, page 22 and page 23 are going to be our homework. So you have 3 proofs. But the first 9 problems, I'm basically asking you to use the vertical angle definition to solve. I'm asking you to use some linear pair information to solve. Is it okay if you take a little algebra break?
Yes, I love algebra breaks.
Okay. Page 22 and page 23. Let's see what we can do here.